So this is 2014 AMC 10A problem 16. In rectangle ABCD, AB is equal to 1, BC is equal to 2, and points E, F, G are midpoints of segments BC, CD, and AE respectively. Point H is the midpoint of GE. What is the area of the shaded region? So in this problem, we're going to label our known angles and sides first. So we have ABCD is a rectangle, so these are all right angles, and the opposite sides are equal. So we also know that EFG are midpoints of BC, CD, and AD. So G is actually a midpoint, and E is also a midpoint. So since these are both midpoints, the side ends here are going to be the same. And we know AG is parallel to BE because of these two angles, and AB is also going to be parallel to GE since we know these two angles are going to be right angles. So this is just some common sense here. So we know that ABEG is going to be ABEG is going to be a square because AB is 1, and GECD is going to be a square because we also know GD is 1. And GH is going to be 1/2, HE is going to be 1/2. So to figure the area of this shaded region out, we have to use difference of areas. So why? Because as you can see, this is obviously in two triangles. So we have two options. So one, we figure out the area of this triangle, and then we subtract it from the area of this. So these two smaller triangles. Another option, we figure out the area of the large triangle. We figure out the area of this triangle, and also the quadrilateral. So I believe that the small triangle HDC seems easier, and figuring out the two little triangles here also seem easier. So let's figure out the area of triangle. So we're trying to figure out the area of triangle HDC, and we're trying to figure out the area of the triangle. So let's just call this point I and J. So we're trying to figure out the area of the triangle DIF, and we're trying to figure out the area of the triangle of FJC. Okay, so this is our goal right now. We have a new goal. So we want to figure out all the variables in this equation and plug it in. So what's HDC? Let's just draw the height. So if I drew the height from H to F, the height is H to F because both H and F are midpoints, so they are parallel to the sides, and this just forms a right angle. They're parallel to the sides. They're parallel and equal to the sides, in fact, because we're in a square. So when HF is parallel to EC, and we already know that GE is parallel to DC, we know HE is parallel to FC. So HECF is a rectangle, so the opposite sides are equal. So HF is going to be equal to 1. So HF is equal to 1, so the area of triangle HDC is going to be 1/2 base times height. So 1/2 base times height, which is just 1/2, because the base is 1/2 plus 1/2, which is 1. The height is 1. So 1 times 1 is 1. So 1/2 of 1 is just 1/2. So we have the area of triangle HDC. Now we need the area of the triangles IDF and JFC. Okay, so let's just drop the altitude, because dropping an altitude seems like the most reasonable thing to do right now. So if I just drop this altitude, over here, so we know that triangle IDF is actually congruent to triangle JFC, because, well, I mean, if you're not sure, then we can just draw another altitude, but what I'm telling you is all we have to do is repeat the same process to get the two altitudes. So we draw two altitudes, and now I try to get the two altitudes. So how do we get this? Because no sidelines are labeled for these two altitudes. However, we have similar triangles. So which triangles are similar? So let me just label this point. So H, I, J, K, L. So I'm going to label this point K, these points K and L. Triangles K, H, I. So let me just write this down. Triangles K, H, I. And triangles F, I, D. Wait, no. F to K, H, I and F, D, I are similar. So why are they similar? Because we know that KH is actually parallel to DF, since KH is on GE and DF is on DC. So we have angles equal, so we have HKI is equal to IFD. We have for opposite angles are equal, so this is angle-angle similarity. So we have angle-angle similarity, and we also know that if we have similar triangles, their corresponding altitudes and also any side lengths, like the corresponding angle bisectors and altitudes and medians, all have proportional side lengths to the ratio of their side lengths. So we want to figure out the ratio of the side lengths. So for K, it looks like GK is equal to HK, doesn't it? So how do we prove this? So basically here, we know that, so right now here, we know that GK and HK look equal, so we want to prove this. So we can prove this by proving, so if we prove this by proving triangle AGK and triangle FHK are congruent, then we can prove that GK is equal to GH. So let's just prove that. So triangle GKA is congruent. So GKA is congruent to the triangle HKF. So how do we know this? We have opposite angles are equal. We have a 90-degree angle, and we also have one side. So we have AAS, so angle-angle side. So since these two triangles are congruent, we know GK is going to be equal to HK, and similarly, HL is equal to LE. So these are all equal. So now we know that, so since GH is 1/2, because H is also a midpoint, GK and KH are both going to be 1/4. So KH is 1/4. We know DF is 1/2. So the proportion of the side lengths is going to be DF over, so we know DF over KH is going to be 1/2 over 1/4, which is 2. And the side length is equal to the proportion of the sides of the altitude. So the altitude here is going to be H, so I'm going to call this H. And this is going to be small h. So big H over small h is going to be equal to 2. However, we know that these two altitudes are on the same line because we have the same vertex and the sides are also parallel. So the altitudes are going to be on the same line. So they sum up, so H plus the big H plus small h is going to be equal to 1. Okay, so basically small h is going to be, equal to 1/3 of big H, or big H is equal to 3 times small h. So we know that H plus H is going to be equal to 1, so so big H is going to be equal to 2 times small h. So we have H plus 1/2 h is equal to 1, we know that big H is going to be equal to 2 over 3. Great, we have the altitude of triangle IDF. Now similarly, on the other side, if you just redo the same process, we have the altitude of triangle GFC. So big H is equal to 2/3. So we know that the area of the triangle IDF, which is also the area of the triangle JFC, is equal to, so H is 2/3, so we have 1/2 base times height, so it's 1/2 times the base, which is 1/2, times the height, which is 2/3. So the answer here is 1 over 6. So that's the area of IDF and JFC. So in this equation, over here, we subtract the area of triangle HDC. We subtract the area of IDF and JFC from ADC. So we have 1/2, which is the area of HDC, minus 1 over 6, the area of IDF, minus 1 over 6, the area of JFC. So after we evaluate this expression, we have our answer. So we have 3 over 6 minus 2 over 6, which is our answer, 1 over 6. So our answer here is the shaded region HIFJ, because we have the large area minus the two smaller areas. So we have the shaded region, which is left. So our answer here is going to be 1/6. So our answer is E, because it says 1/6. So the key in this problem is to figure out how we can figure out the area of the shaded region. And then we have many similar and congruent triangles to figure out side lengths based on the ones that we already know. So thanks for watching.